scientists made a daring announcement, asserting that they have discovered a new planet unlike anything previously known. NASA, known for its revolutionary findings, has revealed that not only is this planet fascinating because of its location and size, but also because it displays light that appears to be created artificially. Close to disclosing information that could improve our comprehension of the universe, this finding may indicate the existence of other planets with life. By exploring the amazing discoveries made by NASA, we will soon discover the truth regarding these extraordinary illuminations. In 2007, with the launch of the Dawn spacecraft, a mission to investigate a few of the most fascinating planets and stars in our solar system, Dawn had 3 ion engines and was capable of beginning a journey that began with a 14-month study of Vesta. The Dawn is the second-largest asteroid in the belt. It sent back detailed images and data revealing Vesta's complex surface and diverse geological history. After achieving its goal at Vesta, Dawn began the second and perhaps most enthralling phase of its journey in detail, thanks to the dwarf planet Ceres study. Due to its ion engines, Dawn was able to leave Vesta's orbit and move in a direction, something other than the conventional. There would not have been chemical propulsion allowed. These engines provided a gentle thrust that made it possible for Dawn to travel a considerable distance away and enter a stable orbit around Ceres. Found in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the asteroid belt's largest object between Mars and Jupiter. For many years, it was thought to be the tiniest dwarf planet in the solar system until its 2006 reclassification. With a diameter of about 950 kilometers, Ceres includes the largest and thickest structure in the asteroid belt, one of the most fascinating due to its individual traits. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots dispersed throughout the surface, particularly in a big crater known as Akator. These bright spots immediately sparked interest and speculation in the scientific community. Before dawn, the best image we had of Ceres was a blurry, low-resolution image taken very carefully by the Hubble Space Telescope. Little was known about this dwarf planet, and the possibility of finally receiving great discoveries was promised at close range. The Dawn mission sought to improve our understanding of the formation of water's role in the solar system and the process by which planets are formed. Bright spots on Ceres, also observed on other asteroids, might be made up of potentially reflective material, salts that remain after water has sublimated. The finding raised the possibility of cryovolcanism on Ceres, a process where volcanic eruptions produce liquid water or brine instead of molten rock. But what exactly are these enigmatic lights, and what clues do they provide about the character of Ceres? They might also be evidence of something like ongoing geological activity, even more extraordinary. Ceres stands out from other bodies in the asteroid belt because of its size, mass, composition, and potential to contain water and ice. Unlike typically rocky asteroids, Ceres features a comet-like composition, implying that it might reveal additional information about the early solar system. After traveling for 2 years, the Dawn spacecraft finally got moving towards Ceres in early 2015, marking a significant turning point as it got ready to give the first close-up shots of the biggest thing in the asteroid belt. As dawn drew closer, images from Ceres increased in depth, revealing a previously hidden world. The initial images showed a cratered surface, indicative of a long track record of impacts. What caught the attention of scientists and space fans were the mysteriously brilliant spots in the pitch-black rocky terrain. As the resolution of the images increased, the scientific community formulated theories about the nature of these bright spots. Were they patches of ice reflecting sunlight, or perhaps something even more exotic? Speculations ranged from mineral deposits to possible indicators of chilly activity. To everyone's surprise, a closer look showed that the brightest spot was not a single entity, but rather a collection of several distinct spots. The most widely accepted hypothesis was that these were deposits of salt created when water sublimated. This suggested that Ceres had, or still has, some form of geological activity capable of transporting brine or water to the surface, where they quickly evaporate, leaving behind brightly reflective traces. These findings challenged previously held beliefs about Ceres, creating a picture of a more dynamic and complex world than had been imagined. The possibility of the existence of brine or groundwater pockets could have profound implications for our understanding of the universe. Our comprehension of the possibilities for the existence of life in our solar system is fascinating. An intriguing dwarf planet, often described as a rocky world covered in ice with a porous surface, is different from most surfaces that primarily consist of rocks and metals. Ceres stands out for its unique composition. Its surface is a mixture of water ice and hydrated minerals like carbonates and clays, which give it a less dense structure than its rocky neighbors. This composition suggests that Ceres has a significant amount of water. Its surface layer is rocky but porous, with ice and other volatiles trapped, making it more like a comet rather than an ordinary asteroid. This dwarf planet is believed to have a distinct interior composed of a muddy, ice-rich mantle and a core high in water, which represents approximately 50% of Ceres's total volume. Ceres's mantle is probably brine and rock mixed together, surrounding a core possibly composed of denser materials, such as silicates. The presence of a substantial amount of water ice suggests that Ceres may have hosted liquid water in the past, especially if its core was heated by radioactive decay early in its history. This internal structure distinguishes Ceres from the asteroids that are nearby and raises intriguing questions about its potential to be the site of geological activity and the part that water played in its development. But that's not all. The discovery of ammonia clays on Ceres suggests that it's possible this dwarf planet formed in a cooler part of the solar system and then migrated inward. The presence of ammonia may lower the freezing point of water, supporting the existence of surface brines. These insights into the history and composition of Ceres not only contribute to our comprehension of this remarkable dwarf planet, but also provide valuable clues about the processes governing the formation and development of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially compared to the more familiar volcanic activities we see on Earth. Unlike traditional molten rock, cryovolcanoes, also known as ice volcanoes, expel substances like water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments where cryovolcanoes on Ceres are found. Cryovolcanoes on Ceres function by allowing water laden with dissolved salt to reach the surface. When the salt water makes contact with the vacuum of space, it rapidly sublimates, transitioning directly from a liquid or solid state to gas. This leaves behind glowing, reflective salt deposits. These salt deposits form the enigmatic bright spots found on the surface of Ceres. The most famous of these bright spots is in a crater called Akator, known as Spot 5. This area has garnered much attention due to its high observed reflectivity and periodic haze observed by Dawn's spacecraft. These hazes, believed to be caused by water sublimation, suggest that activity could still be ongoing or have occurred on Ceres relatively recently. In addition to Spot 5, Ceres hosts several other bright spots, each with its own distinctive features. These locations, not confined to a single area but scattered across the surface of the dwarf planet, indicate that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights Ceres' active and dynamic nature, challenging previous assumptions that it was a geologically inactive world. As the Dawn spacecraft provided more detailed images, a variety of Ceres' surface features started to appear. Ceres' surface is dotted with a variety of craters, each telling the story of the dwarf planet's history. As Dawn continued to orbit Ceres, scientists gained an even deeper understanding of the tiny planet's internal and surface processes. One of the most exciting revelations was the presence of organic molecules. the building blocks of life. In 2017, NASA announced the detection of aliphatic organic compounds in the region around the Ernoutet crater. These intricate carbon-based molecules are commonly associated with biological processes, despite the fact that they can also form through abiotic mechanisms. The presence of brine, organics, and traces of past or present liquid water suggests that Ceres may once have had, or still maintains, the conditions necessary to support microbial life, though no life has ever been detected. The convergence of organic chemistry, water, and internal heat makes Ceres a compelling target for astrobiological research. From a historical and cultural standpoint, Ceres has a special place in the history of astronomy. It was the first object discovered in the asteroid belt and was originally considered a planet before being redefined as an asteroid and later as a dwarf planet. Its changing status reflects the development of astronomical classification systems and our growing understanding of celestial bodies. From a scientific perspective, Ceres is a record of the early solar system. In contrast to larger planets that have undergone significant geological processing, Ceres has remained relatively unchanged. Studying it provides insight into the conditions that existed 4.5 billion years ago, assisting scientists in developing theories about planetary formation, differentiation, and migration.